But what is, as a 15-year-old, I remember, is it could flash a flag and play a song. And that's what I took away from it. But then I learned how to program in Fortran on an IBM 1620, which was the first transistor computer. It was the first IBM transistor computer. It had 10,000 characters of memory. You had to do a 3-pass compile, keeping punch, boy, was that not good for paper because you kept producing punch cards and then reusing them. So I've been doing software for a very long time, 60 some odd years, and I've watched it change, and it's not gonna stop. Software is, as I would say in a minute, is taking over the world. But what also matters and has from the very beginning is trust. I heard a talk by Nicholas Negroponte, who was famous from MIT. And in the late 1950s, the US Defense Department brought him in because there was a group called the National Command Authority, very unpublic group. It was 5 senior military officers who were authorized to launch a nuclear strike in the event of an attack on the United States. And for 40 some odd years, one member of that authority was always airborne. They were in 5 different locations, and they had to do video conferencing. Well, they couldn't do video. It was the link they had was 50 baud, 50 characters per second. That was the total data stream that was available to them, plus a voice call. So what they did is construct identical rooms, and then they had mannequins made of everybody who could be on the National Command Authority. And when you sat down to do the conference, everybody sat in an assigned space. So when you were talking and you turned to them, you were everybody was in the same room with 4 mannequins and themselves. The 50 baud was used to move the eyes. And they tracked eye movement so that you could see where people were looking during the call. And then they had a voice link. That was the maximum way to do trust on 50 baud. But it's a problem that's been around forever in terms of how do you get trust. It's very interesting that we don't think about eyes. And I'm not sure that video conferencing, whether it's WebEx or Zoom, really know the focuses. But as humans, we track eyes. And this is not new research, this is 70 years old, but that's what we look at and where it goes. So this issue of trust in software is profound and been around for forever. So today, software is ubiquitous, it's essential, totally misunderstood. I have been briefing senior corporate executives for 50 years on software, and they just sit there and go, I don't quite get it. It's unregulated. And I remember the first conversations around regulating it go back to the late 60s. And, how do you do it? And no one's ever figured out an answer. And that is a real challenge. And right now, the fears from artificial intelligence are everywhere. I worry that the latest Mission Impossible movie is going to drive regulation more than any other policy debate because the image of what AI can do is going to be set by that movie, whether it's real or not. The idea that there's something buried in a sub sunk in the Baltic Sea, anyway, we don't need to go there. You all know the answer. So civilization or a business or any group of people, in the end, is just a group of people bound together by convention and protocols and bargains. And then you have imperfect links and you have imperfect processors, AKA brains. And civilizations are composed of a network in turn of people and other groups. But we should not be surprised by the fact that changing all of our links to digital has had an impact on how society works. And, we are, which is interesting comment on humans not being able to foresee it. But certainly we've had this huge change. And I used to talk about businesses being a collection of conventions and bargains. Religion is one of those conventions and bargains. It's how we make ourselves work. So the links define us. And this was the genius that Mark Zuckerberg had at figuring out that the social graph was really important and really valuable. And he, there was no work on social graph really until Mark did it. And, he was a sophomore at Harvard. And he got the idea, and then he went off and created a new company to take advantage of it and then got sued. But that's another story. And then if you look at Larry Page's genius was realizing that the way that you evaluated pages on the internet was by the links to them. And what made Google win was the PageRank algorithm, which looked at the links in order to figure out what ranking it should get. So it's, links weren't important really until, the late 90s, 2000 in there. And people began to figure out that's what matters. Now today, the links are digital. And the reason for that, is obvious. It's these things. Everybody has them. I don't know. In New York City, I'm told that the average age at which a child gets a smartphone is 9. I think that's a little young, but but what has happened is these things, Apple Watches, are now upper income families are giving these things out at 6. And so the people, my 10-year-old grandnephew texted me the other day, from his bicycle, which wasn't really safe. But you got to teach him other things about that. But they're growing up that way. I took him to an American football game the other day. And talking to him, he doesn't understand what life would be like if you couldn't do that. It's, we redefine the world. So Mark Andreessen, a little over 10 years ago, said software is eating the world. And everybody goes, yeah. Well, a decade later, I don't think anybody's going to argue with it, right? Software has eaten the world, and it drives everything. So we also have bad software. And this is where it gets complicated. The Boeing 737 MAX had 2 crashes. And both crashes were caused by software. The same program. Now, Boeing and Airbus differ in fundamental philosophy. On a Boeing, if the pilot and the avionics disagree, the Boeing airplane follows the pilot. On an Airbus, it's the opposite. It follows the avionics. And neither decision is wrong, because I'm told by people who've studied this that when they look at accidents, it's 50-50. And you're at a situation where you have to make a decision. So Airbus isn't wrong. I met with the management of Airbus once and talked about this. It's 50-50. But anyway, that's Boeing philosophy is the pilot wins. And on Boeing, that's been true, except for the 737 MAX. And on the 737 MAX, Boeing went out and promised all sorts of performance gains. To get those performance gains, they had to move the engines. Now this will not, the next time you get on a 737, this won't make you happy, but when a 737 lands, the clearance for the engine is 13 inches. That's not a lot. When it comes down on the ground on the runway, 13 inches is the clearance between the engines and the runway. When they moved the engines, they had to move them in order to get, they were at 11 with the new engines, and they thought that was too little. So they then moved the engines. Well, you move the engines on an airplane, you change the aerodynamics of the airplane, and now you had a situation where if the pilot accelerated too fast, the plane would go up like this. It's called the angle of attack. And at some point of angle of attack, the engines lose thrust and the plane drops. So they wanted to avoid that. But Boeing also promised all of its customers that you wouldn't have to retrain a pilot. And anybody trained in the 737 could fly it without retraining on the MAX. $1 million penalty if that wasn't true. So Boeing's solution was software. And they went to a group of $9 an hour contract programmers in India and had them write software that said, if the angle of attack got too high, take the back rudder and put it full horizontal for 5 seconds, which would cause the plane to come down. However, if it kept going too much, then after 45 seconds, it put the rudder hard right for 10 seconds. And 45 seconds later, if there was still a problem, it did it for 20 seconds. The plane's going to crash. I mean, if it keeps doing that, it can't go down. And they did it off of one single sensor. Now, the software worked perfectly. I mean, there's nothing, if you tested the software, as far as I can tell, it performed absolutely what it was supposed to. The problem was it didn't deal with the fact that the sensor could fail. And so the theory, I don't know that it's completely proven, is that a mechanic damaged the sensor on one flight and a bird flew into it on another. Now, somebody in Boeing marketing changed the spec so that there is two sensors, but they made the second sensor an option, and you had to buy it. And so when they wrote the software, they ignored the second sensor. So if they had a second sensor, the software ignored it. And nobody worried about the sensor failing. Now, so it was bad software, right? I mean, software crashed the plane. But it was completely written to spec. So what's really wrong is the spec. And where would the spec come from? And why didn't you have redundancy? And a whole broader set of questions. So I don't know how you certify the software without going back to certifying the plane. And it's a very complicated question. The Air France one is the very similar issue. Now this one, the captain had a girlfriend, nothing wrong with that, but he was in Rio, and the girlfriend came, and the previous day he got no sleep. And he got to the airport and he was very tired. And he just wanted to get to sleep. And in fact, when the plane took off, 10 minutes after it was airborne, he said, "Good night, I gotta go." And he went back to take a nap on board the plane. But at the last minute, they picked up some extra weight, passengers and freight. And so he didn't have enough fuel to make Paris. So he hacked it. And it was a common hack done. He said, "I'm not flying to Paris, I'm flying to Bordeaux." And that's okay, because once he got to Bordeaux, he could get a landing slot for de Gaulle in Paris, and then you're allowed to fly on your reserves. If you have a landing spot authorized, you can fly on your reserves. So he could actually make Paris. But that meant that when they encountered a storm, they had to fly through it, because they didn't have enough fuel to not go through the storm. Every other plane in the sky that night, there were over 140 of them, went around the storm. This plane flew right through the storm because it couldn't deviate. It'd have to have landed someplace for extra fuel. So on the airplane, there's what's called a P2 tube, which measures the speed of the aircraft. There are two of them. They have redundancy. The head flight attendant was smuggling meat from Brazil into France. And so she came into the cockpit and asked them to make the back of the plane cooler because she didn't want her meat to spoil. Well, the coolness on the thing ended up being a cause for the P2 tubes to freeze and to cease giving an indicator. So the central software on the plane didn't deal with the fact that the tubes were frozen. It crashed. And then the pilots lost control of the aircraft. And the plane flew at 600 miles an hour into the ocean. Again, this is the issue of how do you easily go and regulate software? I don't know. I mean, because it's all part of the whole plane, the whole specification. And so looking at the pieces, I was on an A380 taking off from San Francisco, and they had an indicator. And the indicator lamp was on. They knew there wasn't a problem. It was just the indicator. The only fix was to reboot the airplane. Now, for safety reasons, the only way to do that is at the circuit breaker panel, which is in the cargo compartment. So they had to offload all of the cargo compartment so someone could go in and hit the circuit breakers and shut the plane off and then wait 5 minutes and then turn it back on. I emailed the CTO of Airbus and go, "Really now, is this, shouldn't there be," we said, "Well, we want it to be safe. We don't want people mid-flight accidentally doing this because that would be catastrophic." But how do you, I don't know how you do it. And I think that some of the rage that we're seeing in society comes from the fact that people dealing with systems just encounter bad software all the time, and it drives them, to the point of rage, makes them angry. So if I look at my own life, I've lived through, what I would call 8 changes in abstraction layers and how we deal with the systems. Hardware, I've actually written code at the machine level. On the IBM 1620, you could actually code up on a key punch and give machine instructions, and you would actually write programs that way because it was faster, much faster. So if you would do it that way. Assembly language was a breakthrough. I remember the first time I saw assembly language. I mean, it was so much easier than having to remember absolute addresses and write in machine code. Programming languages, again, I really started with Fortran, Algol, COBOL. If you remember, there was well, you won't remember, it's too old. There was a Club of Rome study on how the world was going to die from pollution. And it turned out that all of the analysis in the book that was published, which by the way is still quoted, was erroneous because they used a common statement. And many of you probably don't understand Fortran because there was no reason to, but a common statement allowed you to share data between subroutines, but it was all positional. And so if you made a mistake, you were accessing memory, but it might not be the memory you think. The common statements were wrong. So every piece of analysis in the Club of Rome study was incorrect. But it doesn't matter, that book is still quoted today. Then we got MVS, and again, it's a miracle. I mean, the ability to write, in it it changed the way. It's like Kubernetes was for you guys today. But it's interesting whether Algol had, and IBM MVS had a procedure called IH move, and they were the same thing. The most brilliant programmer on the project would solve problems that other people couldn't solve. And so there are lots of things on the MVS that you didn't know how to do. You went to IH move. And one brilliant programmer wrote that piece of code, and nobody really knew how it did. On Algol, you called Old Weird Harold. And Harold was a programmer who retired. But whenever somebody else had a problem, he'd say, let me think about it. And he'd come back and say, call this procedure with these parameters, and I'll take care of it. And he did. But MVS is still running. I mean, IBM sold $8 billion worth a quarter still of operating systems because it's stable. Then you had Unix, and now Unix has ended up taking over the world. Oops. Then you got desktop environments. And, again, this is a breakthrough. I had to write a paper analyzing whether Windows would beat command line in DOS. That was the time. That was the 80s. There's a paper on Byte about how user-friendly you can be. And this quickly evolved to the web. I've argued with people back and forth about whether the web is something different. But the web did one thing which is really important for Ori, is the web introduced sessionless computing, right? There's no concept of a session. Time sharing was session-based. You had to log in on a time-sharing computer. So I knew identity in the sense that I had that locked into a username that was tied to an account. It was tied, so very different. But that's a change. And that may be the argument that it's 5A or maybe really 6. And then you had smartphones. And smartphones have changed the world, but it's not really all smartphones. I mean, I had a Nokia N95, which was a brilliant device, and you could do it. But until the iPhone, if you wrote software for a smartphone, even if you had a simple application, you had to be phone aware. You had to be phone call aware. And as a developer, you had to write code to deal with, I just got a phone call. Because the phones weren't powerful enough that you could ignore the requirements of having a phone call. Avi Tevanian, who wrote Mach kernel and then became Steve Jobs' head of software, Avi is the one who figured out, wait a minute, if the processor runs at 400 megahertz, then if you're running Mach, voice can just be an application. And that profoundly changed the world. Because until that point, applications were really hard to write, and there were very few people who could write them, and they weren't that great. But the iPhone changed all that because it made voice an application. And then as a developer, you didn't have to worry about the fact that it was a voice call. You could just write your application. So that's profound. Then you get cloud computing. Cloud computing really all comes from a guy named Jim Mitchell, who worked at Sun, where I knew him. And he wrote, he started on it for years. He went to Google, and at Google he wrote Borg. And if you know the history of Google, what gave Google this enormous cost advantage is Borg. And it's just the cloud. Borg was, okay, what do you need? It's just Kubernetes. You need these many servers, this much storage, this much blah, blah, blah. You type it in and it's done. And he started that, and that's grown. And now I think we have what is going to be, the next abstraction layer, and is going to change the world even more, which is AI. And every abstraction layer has changed the role of software and the role of computing. And I think AI is the ultimate abstraction layer in terms of change, because, it can generate code. So, if you need, Adam D'Angelo just observed that one of the things that he's figured out, and Adam runs Quora, was CTO for Mark Zuckerberg at the beginning, was his roommate at Exeter, but one of the brightest programmers around. He's saying he thinks that the LLMs can write better Python than they can write other languages. And he's wondering whether Python is going to get a reboot because the LLMs can do it. We don't understand all the second order effects. But each new abstraction layer has opened up computing to a whole new group of people who then get a whole new group of applications and then appreciate it. It means that innovation is quicker and cheaper. Each layer builds on the ones before, and AI is going to be the most disruptive. Now, the problem is that you have no idea what's happening. I have a nephew writing code on top of Kafka, and all these layers, and he's deep into what Kafka does, whatever. But nevertheless, you're sitting there. You've got so much stuff underneath you. It's very hard to have an appreciation for what is actually happening. So the consequences are we're getting more links between people. More and more things are being done digitally. I can't make a restaurant reservation without getting text messages and emails and notifications and doing it. You get much more software mediation of the links. You get more people are going to be doing it. And Monica Lamb, professor at Stanford, did a project called POMI, Programmable Open Mobile Internet, in the early 2000s. And one of their conclusions was that everyone would end up with a digital butler. And that's where we're headed, right? They maybe have a different name, but it's just, personal AI, whatever. But you're going to all have an alter ego. And if I need to have dinner with you, I'll ask the alter ego. I won't bother you. And your alter ego will understand where I stand in the priority list. One of the interesting things about Korea as society is that you can tell someone that you're in ring 3 of their friends, and you don't get insulted. Because they accept that, and culturally you can have levels of friendship. Most other societies don't, and if you told somebody they're in level 3, you're likely to have hurt feelings. But that's the idea that you're going to have this kind of personal AI, and you can do it now. There's a mutual friend of Thomas and I has already built it. On top of OpenAI, OpenAI, ChatGPT. So we're going to get there. So software is very little understood in the beginning. People really didn't understand it. Little is written in a disciplined way, and that's still, to some extent, true. There's no need to be an engineer to write it. And I have a young friend that she just became a civil engineer, and she's designing things like nuclear reactors and bridges and things like that. She has to be certified. There's testing and things. We don't do that for software. Now, it's been proposed since the 80s, maybe even earlier, but it's never gotten there. So we let anybody write software. And so while it's often been discussed, it's never been implemented. And the biggest reason for certification isn't going to be technical skill, it's going to be ethics. It's going to be ethics and policy and where you go, because that's what governments are worried about. They don't really care whether you use C or Python or whatever. What they care about is that you understand the consequences of what you do. It's something that HR people would call seriousness of purpose. And it's inevitable right now because of AI and the fears. And it's already doing, I think the fears are overstated, but it suits the commercial interests of the companies because they want to ban competition. And regulation right now bans competition and lets you do that. The regulations are being developed by lawyers who don't have a clue what they're doing. There's just so many issues, but I mean, I don't know how to stop this. This trend is already, I mean, you have Sunak in the UK just had a digital summit about how to control AI. I mean, when you've already got that going and 25 nations sign a declaration, it's pretty hard to stop that tidal wave coming at you. You have President Biden in the United States issued an executive order of questionable legal basis trying to do it. The EU is talking about it. In the United States, for the first time, a corporate information security officer has been charged basically with neglect of duty by the Securities and Exchange Commission, which suddenly changes, you take that job, and you don't do, and he's accused of basically minimizing the tech debt that he had and overstating the things. I mean, most of the breaches in the US are phishing attacks. And so I don't know how you hold someone responsible that an employee responded to a phishing attack. I mean, again, identity matters a lot because to do it. But if the person over the help desk answers the phone and says, "Oh well, your password is," you can have lots of precautions, but that goes away. And then to show you how far this will go, Del Campo just announced that they're putting $500 million worth of GPUs on a barge and putting it out in international waters so that no regulation applies to them. And anybody who wants to go do an AI where there's a regulation in the way, no problem. You can go do it. And we have a barge in international waters. And I mean, this reminds me of the pirate radio stations that existed in Europe in the 70s. But I mean, and this is not a minor investment. It's $500 million worth of GPUs. And they're going to go put it on a barge. So again, in modern stacks, you got the user interface, the application logic, the application, the frameworks, the operating system, and now the operating system is running on something that Kubernetes has created for you out of thin air, and you don't really know where it is. And from the studies that I've read, the application logic itself used to be about 5% of the total software running. I bet it could even be a tenth of that now, given how much more has been added in the lower levels. So writing the application has never been the problem. It's putting it into context. So you've got one theme that's coming is people want low code, no code, which is to let end users write their own software. Now, what could go wrong? And I mean, there's a story of Sony overpaid $500 million when they bought Columbia Pictures, $500 million, because there was an error in the spreadsheet they used to justify the valuation. I mean, spreadsheets are low code, no code, right? I mean, they're end users writing their own software. And I mean, people have done studies of corporate spreadsheets, and the percentage that contain material error is very high, sometimes over 90%. I mean, this is really scary when you think about all the power that's sitting below in that stack. What somebody not thinking, I mean, RM star dot star is is the kind of thing that can happen. So now people are talking about, in the open source GitOps and very controlled procedures about how you actually modify the software. And, it's praised by some and opposite by others. You've got machine learning. I mean, Tesla just launched 2 AI training environments. One cost them $1 billion, Dojo, which because it has their own chips. The other, they bought $500 million worth of NVIDIA chips in July and brought that up. Now, again, you've got a complex that, machine learning, I mean, you don't know how doing it, and how are you going to prove, how are you going to test? I mean, you're watching this play out in real time with autonomous driving. And how do you certify that, and where does it go? And I mean, there's a lot of fuss because there's a picture of a woman being dragged under a car, a self-driving car. What isn't in the picture is that a car driven by a human hit her and pushed her under that car. The self-driving car didn't hit her. Another car hit her and knocked her under the car. So, it would have happened if it had been a human in the car. But that led to an uproar that, you've got to go change it. And they took away Cruise's certification. And I don't know how it's happening. You've got automated general intelligence when, it's going to start generating itself. And then you have cybersecurity. And again, when you have that whole stack, cybersecurity, I belong to a user, well, it's not a users group, but a bunch of security and intelligence professionals talking about all this. And it's just very hard. And you're seeing the consequences of security breaches everywhere. In the US, small governments and hospitals are routinely paying ransomware. So there's now a proposed law to ban the paying of ransomware. I had a professor in graduate school, Thomas Schelling, who's very famous because he was the inventor of the concept of mutually assured destruction. And that was the basis of the Cold War strategy. He was the model for Dr. Strangelove in the movie Dr. Strangelove, if you've ever seen it. And he was called in the 70s by the government of Italy. And they were having a number of political kidnappings. And they said, how do we stop these? These are devastating. And he came back and he said, well, I got a simple solution. A few innocent people will die, but less than would die anyway. And all you have to do is make it a capital crime to be kidnapped. So once you were kidnapped, if you were brought back alive, the state would put you to death. And therefore, there's no reason to ever pay the ransom because the person's going to die anyway. Now, this is how he thought. And it's logically correct. Needless to say, the government of Italy did not adopt that solution. But ransomware is just a huge issue. And these people are completely defenseless. They don't understand the stack that's there. They don't, their security things are not there. And the studies that have been looking at ChatGPT generated code show that it's full of security holes. And, maybe it'll get better over time and you'll have another AI that will read it and look for security holes, and that's coming. So engineers, well, I don't think they go away. I think they're essential and live forever and ever in some sense. The top engineers, they're still very scarce. I go through this in the book, The New Technology State. And they're not, there's a reason why they're there. To me, we have no problem understanding why a basketball player who's 7'6" is really good. The problem is that things that are in the brain aren't observable as height. And so therefore we don't understand that some people are just better at software than others. And so the very best. The better you are, all the work I've seen so far says that AI helps you more. The general consensus is that it can double your output and productivity. But you still have to go through and look at the code it produces. You find errors and you change it. AI is going to take over a lot of tasks. There's no doubt that's going to happen. So I think that some regulation seems inevitable. And given that almost every other engineering discipline is regulated everywhere else in the world, the idea that software engineers will be allowed to be not regulated. Now, that could be good because what it means is that certain programming teams will be restricted to registered engineers. And that's the likely course of outcome, in my view. But to be honest, I haven't seen one proposal since the 80s on exactly how you would do that and where you would go. So I think that we're going to be looking at a future where everything comes down to trust. You can't build a secure system unless you have trust, and trust between the applications, trust between the user and thing. There's a issue in the United States right now where 5 states have said that you can't look at adult content unless you're at least 18 years old. Well, the companies go, well, we have no idea how old the user is, so they've just shut off the states. And they hope that will bring a political backlash, but I just don't see people standing up and saying, this is, I really want my porn. I don't think that's a political winner. And go do it. So, trust at the end comes down to identity. And it really is, how do I know who the person is in the end? And more importantly, identity, maybe with some certified attributes that, like conceivably programming environment would want to see that you are a certified engineer. And you couldn't log in to the IDE unless you had those certifications and credentials. The problem is software is merging into society. And all of the conventions and laws that are in society are going to have to, in some sense, merge into software. And we're going to have to figure out a way to live with that and where it goes. So, the reason, and I think the opportunity for ORE is it's all about trust. It's all about, you can build secure identity, which means you can build trust. And that, I just don't see, there's two things I can be pretty confident about the future, is that we're going to require that you have some form of certified identity, and we're going to have some form of regulation on the creation and operation of software. It's going to be hard because low code, no code is irresistible. And also, you can make a lot of money out of it if you provide it. But, that's my view of the world. So thank you for listening. Appreciate it.